Okay, can you hear me?
Yes, sir.
Okay. Can see the new background,
Yes, sir.
the school background now. Zoom can do like that. Use the background. But I have to cover my head because my head is too shining. Otherwise, my head disappear, become transparent. Okay, any more coming in? Yes, Liu Ying. There's Ganga. There is this Ganga. Let me see, not Ganga, Vikashini. Okay, time already. Any more coming in? No, three participants. Okay, right. We shall start. Got some more. Okay. Oh yeah, then I better wait for her. She said she's coming. Atira. Okay. I'm Atira. Some more? Any more? No more. Oh, this where's the girl supposed to come? Really? Oh, got chat ah. Okay. Oh, you came in late. I told already. The background is our school because this one must honor our school. We do it in the name of our school. Okay, Liu Ying can hear me? Okay, then why I wear a hat? If I don't wear a hat, my forehead is very fair and shining. So you will see transparent, my head transparent. You want me to take off my hat? Huh? You want me to take off my hat? Now you see my head become transparent. Transparent, my head. See here transparent? So I have to put on the hat. Then my head will not be transparent. Okay, so I'm now in school, So I'm now in school. Anyone coming in? So we are teaching in school. Okay. So you tell we are teaching in school now. They see the school building behind me. I'm not in school, but I'm in school. Okay. Okay. Right. Now we go and look at where's the screen? Sharing the screen. Google Chrome Sketchpad. Okay. Share. Right. Any more coming in? Any more coming in? Don't know. Oh dear. Okay, this one. Oh, okay, here. Right. Any more coming in? Any more coming in? Can anyone see Bikachini coming? Oh, okay, manage participants. Okay, no, Bikachini not coming. Knock, knock, knock at the door. Okay. No, okay, no, then I don't care really, no. Okay, where is she? Wall. Oh, she wants the email. Okay, so we give her the email. Okay, where's the email? Oh, here. Okay, then compose v Vikashni. Vikasni. Don't have. Okay lah, don't know ah. Never mind. This one go on. Where is she now? You are looking where? You are looking at the. You still cannot find. Just a moment. I go and kasihan her. I go and put this up in the URL in her WhatsApp first. Macam-macam lah this girl. Hey, okay. Vikashini. Okay. Okay. Ready? You should come in. Where? We just wait a while, huh? Wait, the time running up already, loh. This girl so slow. I don't want to wait for her already, lah. Where is she already? Don't want to wait for her. Okay, Vikasini, I mean. Okay. So can you hear me, Vikasini? Megan also want to come. Okay. Can hear me or not, Vikasini? Can, Vikashini, hello, Vikashini, can you hear me?
Can sir, can sir.
Can, okay, right, we start. Now the problem is like this. You have an arithmetic progression and you call this arithmetic progression SA. Then we have another arithmetic progression called SB. Now this SB is actually part of the SA. It is the subset of SA, right? I shall explain. Right. Now, if you look at these terms, 4, 5, 6, 7, 8, 9, 10, let's say they are terms in an arithmetic progression. Now, these terms, they move from one term to another by increasing 1 each time. It means that the common difference is 1. The common difference is 1. So if I want to know how many terms are there from 4 to 10, how to find? We use 10 minus 4, right? Then plus 1. So there will be altogether 7 terms. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. Is it 7 terms? Yes, 7 terms. Okay, we look at another one. This is the actual problem we have here, the SA. Now, SA starts from 2m, 2m plus 1, 2m plus 2, 2m plus 3, until 4m. Now, this series also increase by 1 at a time. Okay, the terms here also increase by 1 each time. So it means that the common difference here is 1. Now, if I want to know how many terms are there from 2m until 4m. How to find? 4m minus 2m plus 1. So the number of terms, 2m plus 1. Okay, right. So next we look at the terms. Okay, the terms. The terms here, 2m, m plus 1, and so on. I call them T1, T2, T3, T4, T5, and so on. So the number written in subscript, they are actually the term number. They indicate the position of the term in the series. So this 1, 2, 3, 4, they are not values of the term. They are not values of the term. They're actually the position, their position in the series, in the arithmetic progression. Right? So far, any question? Anyone? Any question? Anyone new one coming in? Can you let me know? Any new girls coming in?
No, sir.
Yes, one, Hari Dashini. Okay, and okay, right. So now, next one. So no question, so right. So we have this type of term. The one, two, three, they are actually the term number. It is not the number of terms. Number of terms, you count how many terms are there, and that is the number of terms. But this is the term number. It indicates the position in the okay. It indicate the position in the series. Now, when we look at these terms, term 1, term 3, term 5, term 7, these terms, they are known as the odd terms. Are you familiar with this word, odd terms? Okay, now by the same,
No.
no, never mind, then you learn now. In the same way, these terms T2, T4, T6, T8, they are called even terms. They are called even terms. So these terms, they are divided into odd terms and even terms. Okay or not? Okay, right. So next one. Let's take for example, let's say you don't understand, like Vikashini just now, don't know Vikashini or Karen, is it? They said don't understand. Okay, now you look at one example. Now let's say I have these terms here, 7, 9, 11, 13, 15, and so on, right? Now the values of these terms, they are all odd. Can you see the value here? 7. 7 is an odd number. 9 is an odd number, right? So the values of these terms, they are odd. Now, if you look at these terms, 2, 20, 22, 24, 26, 28, these terms, they are actually T1, T2, T3, T4, but the value of the terms, they are even. So can you see the difference between the value and the term number? Okay or not? So, Vikashini, can? Term number and the value of
Can,
the term.
sir.
Can, so they mean different thing, they mean different thing. Term number and the term. Okay, right. I see got anyone coming in? Yes. Wang Wanli. Okay, so these T1, T2, they are term numbers. They indicate their position in the arithmetic progression. Whereas these numbers, they are the actual values. They are the actual values of the term. The actual value can be odd or even, right? Okay, next one. Now you look at this series, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Now, can you tell me what are the odd terms here? Vikashini, can you tell me what are the odd terms here? They are first term,
11. 11.
10,
No,
10,
sir.
10.
No.
This one is T1. This is the odd term. This is T3. This is
Oh.
the odd term.
Oh, okay,
14.
okay.
This
Oh,
is
okay,
the
sir.
third term. So they are all odd terms here. Okay or not?
Okay, sir.
So 10,
Okay,
12,
okay.
14, 16, 18, they are all odd terms. Okay or not? Vikashini?
Okay, sir. Okay,
Okay.
sir.
But you look
Understand.
at their value. Are their values odd number? No. Their values are even number. So
Even.
they can be odd terms. Their value can be either odd or even. It doesn't matter. Okay or not? Okay, so we look at the other one. Now, the same case, we have 10, 11, 12, 13, 14, 15 until 19. What are the even terms in this series or in this progression? What are the even terms? The even terms, they are 11, 13, 15, 17, and 19. So their position in the series is even, but their values are all odd. So far, okay or not okay? Okay, anyone? Okay or not?
Okay, sir.
Okay, sir.
Okay, so if okay, then I will continue. Wait, let me see first. Oh, anybody coming in? No, nobody coming in. 7 of us. Okay, right. So you must be clear whether they are the odd terms or even term. Their values are odd or even. Okay, we look at the next one. Okay, right. Okay. Now we look at this number m. Okay, m can be any number. It can be an odd number or even number. I mean the value, no? I mean the value. Okay? Okay? Right. The value of this m can either be odd or even. We cannot say anything about this value of m. However, if I use m multiplied by 2, what do you think is this 2m? M multiplied by 2 is 2m lah. So what is this value of 2m? Is it odd or even? Yes, it has to be even.
Even.
Yes, it has to be even. Now, if I use this 2m plus 1, even number plus 1, is it an odd number or even number? It has to be,
Odd number.
yes, odd
Odd.
number. So now, can you understand that 2m is always an even number, 2m plus 1 is always an odd number? I'm not talking about their position. I'm not talking about the position in the series. I'm talking about their value. Okay? So in this way, somebody coming in already. Now, in this way, these terms are m, 2m plus 2, 2m plus 4, 2m plus 6. They all have even values. Okay or not? Okay, then these terms, the even terms, they are the skip one. So the even terms, they are 2m plus 1, 2m plus 3, 2m plus 5, and 2m plus 7. So although they are even terms, but their values are always odd. So far, okay or not? You have to understand thoroughly what is before your eyes. Then only we can proceed to calculate using the formula. Who is coming in? Nobody coming in. Okay. Right. So far, you understand, even terms, but they are odd. Odd terms, but they are even. Very, how to say, very ironical, but it is true, right? It looks like something weird and look like I'm talking nonsense, but it's true. So far, if you can follow what I say, that means you know it's true. So far, how many of you cannot follow? Can follow or not? Yes, yes. Then I
Can,
go
sir.
on. Yes or no?
Can, sir. Can follow.
Can follow. Okay, now we proceed. Now this, you look at this series, SA equals to 2m, 2m plus 1, 2m plus 2, 2m plus 3, and so on until 4m. Okay, what is the first term? The first term, 2m. What is the last term? Have you learned about the last term? L? Last term is,
Yes, sir.
yes,
Yes, sir.
last
For
term
M.
is 4m. Okay, then what is the common difference? You take belakang tolak depan, you will get the common difference is 1. Okay, right. Now, I would like to know from 2m until 4m, how many terms are there? So I use 4m minus 2m, then plus 1. So altogether, this SA, or the arithmetic progression SA, has 2m plus 1 number of terms. This is the number of terms. This is not the term value. But the term value is this one, 2m plus 1. This is T2. T2 is 2m plus 1. However, the number of terms is also 2m plus 1. They are equal in terms of value, but in terms of meaning, they mean different thing. Okay? Okay, right. So if okay, then admit this Wan Ying. Where is Wan Ying? Disappear again. Ask her to log in again. Wan Ying. No, disappear. Never mind. Okay, so far, are you clear about this series SA? Okay, clear. Then we look at something like this, SB. Now, SB, they are actually taking out the even terms. They're actually taking out the even terms from the original SA. They're taking out the even terms from the SA. So this SB is actually 2m plus 1, 2m plus 3, 2m plus 5, 2m plus 7 until 4m minus 1. Okay, they are taking out the even terms from the original series. So by looking at this series here, the first term is m plus 1. The last term is 4m minus 1. The common difference is no longer 1. You take this belakang, tolak depan, what is it? It is no longer 1. It is 2 already, right? It is 2 already. Okay, now we so far for the second series, which is the sum of Yang Wan Li. Why this Yang Wan Li go out, come in, you go out, come in again? Okay, right. The first term is 2m plus 1. The last term is 4m minus 1. The common difference is 2. You take this minus this, you will see the answer is 2. But how many numbers are there altogether from 2m plus 1 until 4m minus 1? Anyone can tell me? I said the answer is 4m minus 2m divided by 2. Why? Can anyone tell me why is it?
Sir,
Yes.
can I answer?
Yeah, why?
Because 4m minus 1, then minus 2m plus 1. Because 4m minus 1 is the last term, while 2m plus 1 is the A.
Then must divide by 2. Must divide by
The
2.
divide by 2.
Because the common difference is 2. Earlier on, you don't divide because the common difference is 1. So now you have to divide by 2, right? So I explain one more time here, right? I'll explain here. Okay, further explanation, you look at this. Now, let's say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until 11. I want to know between 1 and 11, how many even terms are there? Can you see here? The even terms, they are 2, 4, 6, 8, 10. How many? 5. Okay, they are altogether 5 even terms. Okay, so I take this, someone coming in. Is it someone coming? No, nobody. So what I do is I take this 11 minus 1, then I know what is the range inside. But then because they skip 1, skip 1, skip 1, so I divide by 2. So I get to know that the number of even terms inside is 5. So far, okay or not?
Sir, that means you must divide by the common difference, the value of common difference.
Something like that. Different, maybe if there's some difference is it's just the depan belakang there, the boundary there, they may have difference. So you have to be very careful. You test with a few real numbers first. You don't straight away apply it into the case. Okay or not? So you test
Okay,
first.
sir.
You test first. So now I'll give you another example. 44, 45, 46, 47 until 52. Oh, you know how many terms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are altogether 9 terms. Inside there are altogether 9 terms. Now, how many of these are even terms? How to do? We use the same way there. Okay, use 52 minus 44 to know inside got how many numbers, then you divide by 2. So you know altogether there are 4 even terms. Okay, how many? 1, 2, 3, 4. Yes, indeed, there are 4 even terms inside from 44 to 52. Okay, right. Any
No,
question?
Sir?
sir, I
Yes,
got problem.
yes, yes.
Sir, but here there's 9 terms, what, sir, but 52 minus 44 is 8 only, what, sir.
Sorry.
Here got
Ah,
9 terms, right, sir, from 44 to
1,
52.
2, 3, 4, 5, 6, 7, 8, 9. Correct. 9
But
terms.
then 52 minus 44 is 8 only, what, sir.
8 divided by 2, 4. So they are altogether 4 terms. 1, 2, 3, 4. 4 terms. 4 even
Also,
terms
no need to
inside.
plus 1, lah, sir.
Sorry?
No need to plus 1.
Um, unless you want to include the number in front, then you plus 1. If you want to find the original series, how many numbers are there? Because when you take 52 minus 44, you are actually throwing away the 44. So after you get the result, you have to add back 1 because the 44 is considered as one term. Now, however, if you want to find inside one, then you throw away the first number is okay. You throw away the first number, they are actually altogether 8 numbers, which is 4 pairs. So exactly it match exactly. Okay, now?
Oh, okay, sir.
Okay,
Okay,
right.
sir.
Sir,
Yes.
sir,
Yeah.
if we want to find how many odd terms, so is divide by 1 or is the same thing?
Odd terms, you take this minus this, you have to plus 1. Because the odd term include the
Okay.
44. You have to plus 1.
Okay.
Okay, right.
Yes, sir.
Okay. So these things are there's no definite rule. You try a few times with a few examples, a few numerical examples to see the pattern, then you apply it to the general rule, general ones which has the M there one. Okay or not? You try with numbers first, then you see your method can work, then you apply to them. That's why I give you the two examples here. They are totally different, right? Yeah, you have to add 1 if you want to find the odd terms. You add 1, it become 5, right? 1, 2, 3, 4, 5. You have to add 1 because you throw away just now. You throw away 44. When you minus that time, you throw away 44. So when you divide by 2, you get how many pairs, but you have to add back the 44 there. Okay? Okay, Karin, okay or not? Okay,
Okay,
noted.
sir.
Okay, you understand why you have to add back the 1. Now, there's no definite rule. There's no fixed rule how you must do. You see with numerical examples, you see how, then you apply it to the general with M. Now, we look again at the SA, the original arithmetic progression SA, right? Okay, right. Okay, so this SA is m plus 1, m plus 2 until 4m. The first term is 2m. The last term is 4m. The common difference is 1. And the number of terms is 2m plus 1. So far, do you agree with me? Agree with me? This series? These are the, how to say, the parameters. These are the parameters for SA. So this SA, they have parameters. The parameters, they are first term, last term, common difference, number of terms. Okay? So far, you agree with me? These are the parameters of the SA. Okay.
Yes, sir.
Okay. Now, I want to apply the sum of terms.
Yes, sir.
I want to add up all these numbers. Now, to add up all these numbers, I use the formula n over 2 into a plus l. Have you come across this formula before?
Yes, sir.
Yes, you have come across this formula. Okay, so now n is actually this number, n plus 1. Can you see from the top, I substitute inside? Then n over 2, a plus l. A plus l. A plus l. So simplifying, you have 3m bracket 2m plus 1. Simplify, I assume that you are very proficient in your algebra, in your mathematics. I don't have to go through that with you. I just go through the additional mathematics part. Okay, right. So I assume that I explained to you, you have to what formula to use, what to substitute in, and the rest I assume you know how to do, right? Okay, now we look at the SB. We look at the SB. Okay, now the SB is 2m plus 1, 2m plus 3 until 4m minus 1. Can I say that the first term is 2m plus 1? Yes. Can I say that the last term is 4m minus 1? Yes. But the common difference is no longer 1. The common difference is belakang tolak depan is already 2. Okay or not? Applying the same method that we use here, this one, this a minus l, then divide by 2. We apply the same here. Yeah, just now we try out with numerical examples, and this method we can see clearly how to calculate the number of terms. Okay, so here uh, 4m 4m minus 2m divided by 2 and is equals to m. Now this m is what you know. This m is the number of terms from 2m plus 1 until 4m minus 1. However, this 2m minus 4m, I take it from the original series. From the original series, I count how many terms are there in these even terms. In these even terms. Okay or not? Is it very confusing here? Anyone? Is it confusing here?
Very confusing, sir. Yes,
Huh?
sir.
Who
Yes,
said
sir.
Bikasini? Huh? What?
Yes,
What's
sir.
what's your problem?
So from where you take why from SA, sir, suddenly?
Because from SB we cannot know how many terms are there. Because they keep on skipping, we don't know how many terms are there. It is only from SA we divide by 2, then only we know how many terms are in between. How many terms in between? The skipping one, the even terms. Okay or not? If you look at the
Oh,
even term
okay, sir.
itself, you don't know how many terms are there. But by looking at the original one, we know it is just half of it because they keep on skip one like that. So it's half the number. Okay or not, Vikasini?
Okay, sir.
Huh?
Okay, sir.
Okay,
Okay.
right. So
Mm.
how to calculate? Now, I show you how to calculate, right? We use the same formula n over 2 bracket a plus l, right? N is the number of terms. Number of terms is here. We obtain from the original series. The number of term is m over 2 lah. A plus L. A is this one lah. 2m plus 1. L is 4m minus 1. 4m minus 1. So simplifying, the answer is 3m squared. Okay, 3m squared. Okay, so this is my value for SA. This is my value for SB. How to divide the two? Okay, when you divide the two, you put SA at the top, SB at the bottom, and you see that they can cancel off and leaving this only m plus 1, 2m plus 1 over m. So I try to break up into two terms, 2m over m and 1 over m. So 2m over m is 2. 1 over m is 1 over m lah. Now if you compare this format with the given format k plus 1 over L. What is your value of k?
2.
2. What is the value of L? L is at the bottom. What's the value of L?
M, sir.
M. So that's all. Okay. So k is 2, L is M. Any question? Any question so far? If no, then we can stop already. It's already 40 minutes coming up.
Sir,
Yes.
sir, not L is 1 over M.
Not all in one formula. What do you mean by not all in one formula?
No, I thought L is 1 over M.
L is 1 over M. No lah. L is the bottom one. Can you see it's 1 over L? L is the number at the bottom. So 1 over M.
Okay, sir.
M is the number at the bottom. So L is M.
Okay, sir.
Okay. Any more question, Bikasini?
Sir.
Okay. you very lucky you find the correct person to ask this question. Bikasini.
Yes, sir. Yes, sir.
you find the correct person to ask. Okay, no, then I will stop sharing this screen, then we come back here. Okay. No, then I stop